Hello everyone, I want to walk you through the derivative of the natural log function. So just like e to the x has a rule, and that is copy times the derivative of the power, the natural log also has a rule, and it's a chain rule. Okay, so if you have the natural log of some function, the very first step is always 1 over the quantity to which the natural log is applied. So whatever is right after the natural log. As usual, with the chain rule, as soon as you drop whatever was after the natural log to the denominator of this fraction, you have to remember you didn't do anything with it, so you need to finish this off by disintegrating that brick, and you're going to multiply by the derivative of the power. Okay, so the real rule of the natural log is 1 over whatever's after the natural log, and then clean it up by taking the derivative of the power. Alright, so let's try a couple of these. So if you have, and this is number 2 on page 3 of the notes. So if you have f of x equals the natural log of 5x, then your derivative f prime of x equals 1 over 5x. Notice there's 5x after the natural log. There's a 5x right there. Do not take its derivative. I'm going to put a box around that to remind myself I didn't take the derivative. That's fine. So in order to clean this up, you multiply by the derivative of 5x, which is just 5. All right, so oftentimes you're being asked to rewrite this. So I'm going to make this 5 over 1 so that I can multiply straight across here and multiply straight across there. So then f prime of x equals 5 over 5x, or just 1 over x. Like that. All right, let's try another one. Okay, so this will be number 4, which reads that g of x equals the natural log of 2x plus 1. Okay, so here we go. G prime of x then equals 1 over 2x plus 1. Notice I'm not doing anything to the chunk of information that came directly after the natural log. So we want to finish up this derivative, because notice that was a brick, it was constant, it's unchanging. By taking the derivative of the brick, let that brick disintegrate, if you will, and the derivative of 2x is 2, derivative of 1 is 0. Okay, so again, let's try to simplify that. Multiplying straight across, this equals 2 over 2x plus 1. Now at this stage, a lot of students try to cancel. They'll try to cancel there, but you can't, because in order to cancel something, you need to be able to factor it out of the numerator and the denominator. So notice there's a 2 in this piece, there's a 2 in this piece, but there's no 2 here, right? So if this was like a 4, then yes, you could say you could divide out a 2 in every single piece. But I want to remind you, unless the number is in every single piece, then you can't do anything. And this is our final answer. All right, so let's move on to number 6. And 6 reads that h of t equals 2 times the natural log of t to the 5th power. So then h prime of t equals, okay, you can always pull out your coefficient and then focus on this natural log piece. So we have 1 over t to the 5th. Notice t to the 5th was after the natural log, t to the 5th is there. Times, okay, that was your brick, your unchanging piece. So we need to clean it up by taking the derivative of the brick, 5t to the 4th power. Like that. Okay, so again, since we have a number multiplied by something else, we should be able to combine this. The 2 is over 1, this 5t to the 4th also over 1. So I'm going to multiply straight across. H prime of t then equals 10 t to the 4th over, and multiply straight across for the denominators as well, t to the 5th power. So this equals 10. And then there's 4 t's in the numerator that cancel with 4 t's in the denominator, so over t. Okay, so let's move on, do a couple more. What about 8? Which is f of x equals the natural log of the square root of x plus 1. I'm going to rewrite this as f of x equals the natural log of x to the 1/2 power plus 1. Okay, so basically I just took the square root and I converted it. Alright, so let me get to the derivative. F prime of x then equals 1 over x to the 1/2 power plus 1. Notice I haven't changed this. That's my brick. Now to finish this off, disintegrate the brick. Take the derivative of what's on the inside. Okay, this one requires a power rule, right? Bring the power down one less. So 1/2 x to the negative 1/2 power. And then the derivative of 1 is just 0. Like that. Okay, so then f prime of x, right? It wouldn't be a bad idea to rewrite. So 1 over the square root of x plus 1. And then this piece over here, let's see, 1 over 2. 1 over 2. And then this x has to go on the denominator because of that negative power. So 1 over x to the 1/2 power. So obviously I'm doing this in steps. And then the last thing you would need to do is rewrite this x to the 1/2 power. So then you get f prime of x equals 1 over the square root of x plus 1 times 1/2 times 1 over the square root of x. Okay, so that's one version of a correct answer. All right, let me do 10 also. Actually, I'll do 20. So 20 reads that f of x equals the natural log of x cubed minus 3 to the 4th power. Okay? So the natural log is being applied to all of this, right? So the natural log of x cubed minus x 3 to the 4th power. So to remind myself of that, I'm going to put a big bracket around that. So then if we do f prime of x, this equals 1 over all of that. So x cubed minus 3 to the 4th power. The entire thing. Okay? So now, as I'm taking the derivative, I have to be really careful because I want to take the derivative of all of this, including the fact that you're raising it to the 4 power. So if I think about this piece that's in the box is x cubed minus 3 times x cubed minus 3 times x cubed minus 3, obviously 4 times. So when I take the derivative, I have to keep in mind that the 4 is the most important thing to take care of first. So bring the 4 down, 1 less power, right? So you have to do the chain power rule. This inside, leave it alone, x cubed minus 3. And then you finish off your derivative by taking the derivative of that inside piece, 3x squared. So you have a lot of things going on. Now go over that one piece at a time. First, you have to deal with the natural log because the natural log is of all of that. So natural log rule is 1 over the quantity to which the natural log is being applied. The second thing you're going to have to deal with was the fact that you dropped something to the denominator and you didn't touch it. But the derivative of what's in here is with respect to the fact that you have a 4 as a power. So you had to start off by doing the power rule. Bring the power down, 1 less. Inside stays the same. Finally, take the derivative of the inside. Okay, so if you put this over 1, put this over 1, put this over 1, and if we multiply straight across, it's going to be rather large. Okay, so 1 times that times that times that gives us, let's see, 12x squared times x cubed minus 3, the quantity cubed. And in the denominator, we have x cubed minus 3 to the 4th power. Okay, so almost there. Notice you have 3 sets of x cubed minus 3 in the numerator, and then 4 sets of x cubed minus 3 in the denominator. So 3 of them should cancel. So then f prime of x equals 12x squared over x cubed minus 3 to the first power.